All right, welcome back. Dr. P here. And in this lecture, we're going to take a look at the concept of bond dissociation and energies. Bond dissociation energies. Now, what are bond dissociation energies? So bond dissociation energies given by the letter D, capital D, bond dissociation energy is going to be the energy required to break a bond homolytically. So, for example, let's say we had HH and we break that bond homolytically. So one electron to each hydrogen. And in this case, we can look up what the bond dissociation energy is, and there happens to be a table in the text. And I can see here that indeed there's my hydrogen, so my bond dissociation energy is 436 kilojoules per mole. You can also look at it as the bond dissociation energy is the amount of energy released when a bond forms homolytically. So if two hydrogen radicals come in contact with each other and form an H2 molecule, you will release 436 kilojoules per mole of energy. So really the most useful thing about bond energies, bond dissociation energies, and we're not going to do much with them quantitatively. We may talk about them qualitatively, but typically not too much quantitatively, but you could. Okay, so we can use BDE, bond dissociation energies, to calculate delta H naught for reaction. Okay, and what does that look like? Well, let's say we had, I don't know, let's do this. Let's do methane, and let's go ahead and chlorinate it. ClCl reacts to give us HCCl. So you remember the free radical chlorination of methane plus HCl. So I can now look up my bond dissociation energies from my table. So I know that for methane, here we go, my CH bond dissociation energy is 439. dkJ per mole. And then my chlorine bond dissociation energy is 242. Now my CCl bond dissociation energy is, where is that? CH3Cl, so 350. And my HCl bond dissociation energy is 431. And now, again, I've got multiple bonds here, but the 439 for methane just applies to one CH bond. And the 350 for chloromethane applies just to the CCl. So our overall delta H is going to equal, delta H naught, is going to equal the sum of our bond energies for our bonds broken minus the sum of our bond energies for our bonds formed. And now I could go ahead then and say that delta H naught equals 439 kilojoules per mole plus 242 kilojoules per mole minus 350 kilojoules per mole plus 431 kilojoules per mole. And getting my trusty calculator, that is my phone, out, I've got 439 plus 242 equals that, minus 350 equals that, minus 431 equals minus 100. So just by comparing the bond energies of the bonds that we break and the bonds that we formed, we can get an overall view of whether the reaction is exothermic or endothermic and how much. So this is useful-ish. Again, these bond dissociation energies are for homolytic bond cleavage. So although we will use them often just to refer as, you know, the bond energy for something. What's the bond energy? If we're undergoing polar reactions, these don't quite hold in the same way. But they give us a ballpark, and they give us a way of getting at relative energies of products versus reactants, which will help us get at our relative energies. Now for this problem, this example, what do you think delta S naught would be? Let you think about that. You can pause and think, discuss with your friends. Well, let's think. If this was all gas phase, I've got 2 moles of gas and 2 moles of gas. 2 moles of gaseous reactants, 2 moles of gaseous products. I don't have a change in my moles of gas. So my delta S is probably going to be really close to 0. Same disorder on both sides, which means my delta G naught is going to be close to delta H naught. So this is actually a pretty reasonable stand-in for the delta G naught for the reaction. And we could calculate the equilibrium from this as well. So I did want to introduce you to bond dissociation energies, even though they're not something that we're going to deal with a lot, and they won't be featured on the quiz or exam. All right, so I actually think that the next lecture video is probably one of the most important, and so you'll definitely want to watch that. Until next time, stay safe out there. Bye now.